Yeah. So
I let, yeah,
I want to ask about the questions.
wait, let us complete this one first.
Okay.
Then we go to the question. Right. This one is power rating for each device, the time, how long you use it for, and then how to calculate the kilowatt hour, the energy lah. Electricity is widely used in industry and in home, in appliances, for example, motors, refrigerators, shavers, and hair dryer. These appliances have a power rating. Right? Each of them has how much energy it consumes. Power rating is the rate at which electrical energy is used by the appliance in unit time. Right? This is the 850 joule is used in 1 second. No? Okay, so you multiply out, will give you the total energy used by this digital clock. And then if it's 6 pence per unit of electricity, then you can calculate. Oh, total is 6.45. Very simple calculation only. Okay, so it's about 39 pence. Okay with that?
Okay. Yeah.
Okay, what question you want to ask?
Uh, Question 3.
This one you can solve. Number 2,
A. Oh yeah. Yeah. This one I haven't do yet. Oh, new draw graph. I didn't know that.
this one you draw the graph, then you can see lah.
Oh, okay.
Actually, then you can see. You are asking about self-test number 3.
Yes.
Oh,
No, the question after this.
this one
No, no, no. The question below the question 2.
Oh, can you do this one?
Uh, this one, this one I didn't know how to do, but I can really.
Just area under the graph, lor.
Oh yeah.
Right? Draw a sketch of the graph, what it's saying, and then charge flowing is area under the graph, change to SI unit. Right? Can either calculate as area of triangle, area of rectangle, or area of trapezium. 20 plus 12 and 10 to the power minus 3, change your milli to ampere. 10 times 5, right? 5 divided by 2. Sorry.
Okay.
Okay,
Yeah.
okay, let's try number 3 then. Copper or cross-sectional area 8.0 millimeter square carries a current of 5 ampere. Calculate the drift velocity where the number of charge carrier is 8.4 times 10 to the power 28 meter minus 3. Use the formula given in the formula sheet. I is NQAV. Put in the formula. Current is 5 ampere. Current is 5 ampere. N, that's your N. Q is charge on electron or charge on proton.
Oh, so Q is fixed variable, is it?
Q is charge on electron. Can get from the
Oh,
formula.
Q is the charge of electron.
That one you
Okay.
need to memorize or get from formula sheet. A is the
Oh,
cross-section area. Change it to meter. Then 10 to the power minus 6. And then V is the drift velocity. Solve it.
I just didn't know the value of Q.
You must know where to get your from the data sheet.
Yeah.
Charge on electron or charge on proton, the same. Magnitude is the same. Okay,
Hmm.
how about this one? Two copper wire are joined together and carry a current as shown. Wire A has a diameter D, wire Q has a diameter 2D. What's the ratio of drift speed of free electron in wire A to average drift velocity of free electron in wire Q? Can go to the formula, use the formula that we just used. This is
The
207,
just now one, right?
paper 1, 2. Can,
Just now's formula, is it?
yeah, this formula,
Ah, yeah.
then A is a quarter by D square. Right? Take all the constant and group it under C. Right? Current is constant for series circuit, for series flow. And put in the formula. C is just a constant. We consider of 1/4 pi and Q. N and Q are the same for both wire. Both wire are the same conductor, same type. So same Q and same N. Can? The answer is donkey.
Oh, yeah. Okay.
Same. This one we just did. Try and see. Can?
Wait, I'm calculating. The diameter, the must I convert to meter?
Yeah, you have to convert everything to SI unit.
Okay.
Can or not? Can or not?
Yes.
Just use the formula, that's all. You want to find V, subject V, current, number of charge carrier per unit volume by R square. Diameter is divided by 2, change to SI unit, meter, and square that. And then charge carrier is a charge 1.6 and 10 to the power 19 coulomb. Use your calculator, get the answer. Okay, number 6. What's the answer? Basically, I'm trying to get you to use the formula as well.
Okay.
This will be worth 1 mark. Simple calculation. Yep, what's the answer?
Work done is W.
Work done is equals to V times Q.
V times Q. So 12 times
Remember to
what's
change
this?
it to Coulomb,
Meter?
mi-
what's this?
millicoulomb, millicoulomb.
Oh, millicoulomb. Okay. Oh wait, change to what again?
Change to Coulomb, lor. Times 10 to the power minus 3, lor. Just like millimeter to meter, change to
Oh,
the power,
millimeter. Oh, okay, okay.
right? Times 10 to the power minus 3, lor, if it's milli to Coulomb.
Yeah, I got 36,000.
Huh?
No, 360,000.
No, minus 3.
Oh yeah, sorry. Yeah, 0.36.
Ah, calculate this one. What does this mean? It means that when PD across the bulb is 240 volt, the energy dissipated in 1 second is 120 joule. That's all.
Ah,
Calculate the current in the bulb. Should be able to get your answer. Use the formula that I've given you. Charge flowing through the bulb in 5 seconds. Okay, can get the answer.
oh yes.
So it should be completed B and C already.
Sorry, what's the C answer again? Is it 2.5?
Yep,
Okay.
your charge is 2.5 coulomb. Then use the resistance formula to calculate the resistance energy liberated in 5 seconds.
480 volts.
Yeah, 480 ohm. Okay,
Uh,
should be able to do up to E.
I think E is F. Type wrongly, is it?
Oh, maybe I didn't correct the mistake lah. E is the cost, oh, 6 pence. Oh.
Yeah, E. Oh,
We won't bother number 8 lah. Let's go to our lecture now.
okay.
The rest you can do yourself lah. Okay, we go to 9.3, resistance and ohm, page 222. These are all the formulas that we have either derived or defined. Right? That you need to know how to use them. That's the syllabus. That's a symbol for resistance. Right? The old one is zigzag like that. Lah. The new one is just a rectangle. And the same potential difference is applied across different type of conductor, different quantity of current flow. Some conductors offer more opposition or resistance to passage of current than others. Remember, current is the flow of positive charge. So some conductor oppose the flow of charges. Electrical resistance of conductor is a measure of its opposition to the flow of charge. Right? Flow of charge is the current. Right? That one you can read yourself. We have more or less gone over. Basically, the positive ions in the metal are vibrating up and down. The electron is, if you have a potential different from a battery, the electron will be accelerated. So it will collide with the positive ion, give energy to the positive ion. So it lose energy. So that's why you need to give it energy. That's why you have to have a battery or cell to give energy to the charge carrier to continue to move with constant current. Right? So temperature of the conductor will increase. The positive ion will vibrate with greater kinetic energy and greater amplitude. Okay, resistance of conductor is defined as the ratio of potential difference across it to the current flowing through it. Memorize. Right?
This
So
one is the V equals IR one.
say again.
This one is the can derive using the V equals IR.
No, cannot. When it comes to definition, it's specific. This is a definition
Yeah,
for
yeah,
resistance.
yeah, because potential difference uh
P
over
equals to I square R is a derived formula.
no IR.
P equals to IR. Yeah.
Okay.
You can use that. It's the same. It's the same. You just cross multiply the I, that's all. Potential difference is in volt. Current is ampere. So volt per ampere equals to 1 ohm. Right? The Greek alphabet or Greek letter is called omega. So 1 ohm is a measure of the resistance of a conductor in which a current of 1 ampere flows when a PD of 1 volt is applied across it. Or 1 ohm is 1 volt divided by 1 ampere. Measurement of resistance, right? That's the circuit. Component can be a lamp, can be a piece of wire that you are interested in. So that's your current flowing through the component, and then your voltmeter is across the component. Ammeter measures the current and is always in series with the component to be measured. Voltmeter is always parallel or across the component to be measured. Resistance can be calculated from the ratio of voltmeter reading to ammeter reading. That's one way to measure resistance of component. Right? Or we can use ohmmeter. Right? Total resistance in the circuit can ohmmeter. Use the ohmmeter. Right? Ohmmeter straight away give you it has an internal battery. So you can straight away measure the resistance of a component or diode or wire. Right? You must know how to read the circuit diagram. And then from circuit diagram for paper 3, you need to draw to set up the apparatus. Right? That's your battery, series of cell battery. And then that's your ammeter. That's your ammeter. Right? That's your circuit there. Right? Usually the red one will go to the positive terminal, red wire. Right? It's just a convention. It doesn't mean that it doesn't flow if you put a black one. It's just that it helps us to know where is the higher potential.
Yeah.
And that is a resistor. Right? That's voltmeter is across the resistor. Voltmeter across the resistor. That's all. Calculate. What's the answer? Should be able to calculate this simple one using our formula that we just defined. Okay.
Yep.
Ohm's law. Current flowing through a conductor is proportional to the potential difference across it, provided physical conditions remain constant. Example of physical condition will be temperature. Temperature doesn't change. Ohmic conductor. Material that follow Ohm's law is called ohmic conductor. Graph of current and voltage of an ohmic conductor is a straight line passing through the origin. Right? As we can see from our formula here, right? The gradient is 1 over R. Okay, so our gradient is 1 over R, or resistance is the inverse of the gradient. No?
Okay.
Metal follow Ohm's law. Most other materials, the resistance is not a constant and changes with applied voltage. Some of the physical conditions of interest to us, right? Note that Ohm's law only applies as the resistance is constant, provided physical condition remain constant. Physical condition that can change the resistance of conductor include temperature. Right? Temperature rises, usually resistance will increase. Strain, stretching it, light. Temperature, right? Metal resistance increases with temperature. In most practical circuit, heating is an unavoid. Cannot avoid. Electron flow will collide with positive ions, so there will be heating. Consequence of passing a current through a conductor, so the resistance of a hot component in the circuit will be more than when the circuit is switched off and they are cold. Right? The other one, strain, stretching it, apply stretching force to a wire, makes it longer and thinner. This increases the resistance of the wire. Right? Determine the IV curve, current versus potential difference curve for a component. Test your back, test yourself. Variable power supply. We can use this circuit to study the current changes as a PD across the component changes. Right? Can measure the PD across a component by a voltmeter and the current flowing the component by the ammeter. Note that the voltmeter and ammeter reading as the power supply is increased, it changes the power supply. And plot a graph of I versus V. That's a symbol of power supply. So you want to know how V changes with I. Ohmic conductor. Right? These are non-ohmic conductors. Do not obey Ohm's law. Example, diode. That's your diode. That's a symbol for diode. Thermistor. That's a thermistor. Filament lamp. Right? This is for your info. Usually it's coiled up. Right? It's coiled up. Instead of putting in a straight line, you curve. This is for info only. No need to bother about it. Okay, but how does the graph look like? That's how the graph look like. How does the resistance change with temperature? As temperature increases, or another way
Yep.
of saying is the PD increases, the gradient of the straight line from origin decreases. right? A straight line. The gradient decreases. The resistance is 1 over the gradient. Resistance increases. So, okay or not?
Okay.
As current increases, PD across the lamp increases so that the temperature increases. So R is 1 over the gradient of the straight line from origin. The resistance increases. Slope of tangent to the curve follows the trend of the slope of the straight line from the origin. Right? Cannot use the slope lah, right? But follow the trend lah, right? You want to find calculate resistance, it must be the straight line from the origin. 1 over this gradient, not the tangent to the curve. Okay, tangent to the curve is rate, but we did not define it as rate. We define resistance as a ratio of V over I. Right? Lamp is marked 6 volt, 0.2 ampere, or 6 volt, 10 watt. It means that only at this condition is called normal operating condition. That means you must provide 6 volt. Lo. If it's less than 6 volt, then it doesn't dissipate 10 watt. Lo. Doesn't give you the brightness that you want. Right? Normal brightness. So from the 6 volt and 0.2 current, you can calculate the resistance. No? So if the current is too low, the temperature will be lower and the resistance would also be lower. Right? So you have to, when you use the lamp, it may not light up unless you provide 6 volt or a current of 0.2 ampere also. Okay.
Teacher, how about 10 watt?
Say again,
How about 10 watt?
either 10 watt or some bulb will give you current, but usually it's given in watt.
Oh, means like it needs 10 watt to power up, is it?
That
At
means
least 10 watt.
if you give it 6 volt, then it will give you 10 watt of
Oh,
energy. No?
so I give 6 volt, then come out 10 watt lah.
Ah,
Okay.
if it's less than 6 volt, then you won't get 10 watt. No? That means you
Okay.
won't get normal brightness. So. Okay.
Yeah.
Some lamps, when faulty, the filament breaks, thus giving an open circuit. No current can flow. It means open circuit, no current can flow. Others cause a short circuit, thus can damage the power supply as a lot of current will flow through the power supply. Right? You never connect wire to a battery. The battery will heat up, the wire will heat up, the battery will spoil. Right? This is called a short circuit.
Wait, what happened?
The power supply will damage.
Because the wire,
It's flowing. Short circuit.
too short, is it?
There, the two wires short out.
Oh,
So a lot of
how
current
come?
it will damage the power supply or damage the battery. Okay,
Oh, okay.
semiconductor, that's how the graph will look like. That's a symbol. How does the resistance changes with voltage? Right, as before, is 1 over the gradient of a straight line from the origin. So as voltage increases, the gradient increases and the resistance decreases. That gradient, the broken line, that gradient increases, so the resistance decreases. Right, this is called forward bias. What does it mean by forward bias? Direction of conventional current. Yes, direction of conventional current is the same. Okay, we are finishing in 10 minutes time. Direction of conventional current is the same as the direction of arrow of the diode. Rectifier conduct and has zero resistance. Right? When it's forward bias, you can consider as a conductor, zero resistance. Real diode has low resistance. Right? Ideal one has no resistance. Ideal one is in the mind of scientists only. Reverse bias, you should be able to recognize. Right? Direction of conventional current. Right? Conventional current is that way, opposite to this arrow. Die is not conducting, so it has infinite resistance. Real diode has high resistance. You cannot never have such thing as infinite resistance. It's just high resistance and negligible current flow. Uses when changing electric current is alternating current to direct current, which you call rectification. You study in A2. Okay, IV characteristic, you should be able to recognize that. Blue is Ohm's law. So I and V increases at the same rate. That's the blue line. The red line, V increases faster than I. If it curve that way, then R increases with V. Yellow is like the diode, where I increases faster. Right? Increases faster, you can look at the same V. There's your I, but I increases faster. So R decreases with V. Right? You curve that way, the resistance decreases with increasing V. Okay, resistivity. There are three factors that affect the resistance of a specimen of material. Temperature, dimension, that means the length, the cross-sectional area, the material which the specimen is made, right? The type of material. So we define the term resistivity. Property of material that affects its resistance is called resistivity of the material and is given by a symbol rho. Right? Length of conductor is L, cross-sectional area is A. So our resistance is rho L over A. Allow us to compare the resistance of different material. Right? Resistivity allow us to compare resistance of different material.
Teacher, I want to ask,
Yep.
all this formula, does the exam formula sheet have?
No, this one is not in the formula sheet. This one you have to memorize.
Oh, okay.
So resistivity allows us to compare the resistance of different material of the same length and same cross-sectional area. That's what it means by resistivity. Thus, resistivity is the resistance of conductor of unit cross-sectional area and unit length.
Teacher, is rho a constant? The symbol
Yeah.
rho.
Say again.
The symbol rho, is it a constant?
It's a constant if the temperature is constant. No?
Oh, okay.
Depend on material. So resistance is measured in ohm. Cross-sectional area is measured in meter square. Length is meter. So the unit for resistivity is ohm meter. Right? Yes. No need to memorize. Just know that resistivity is quite low for conductor. Metal has low resistivity. Non-metal has high resistivity. Right? That's non-metal. Then the power 4 or insulator quite high.
Teacher,
Yeah.
low resistivity heats up faster, right?
Low resistivity means it has a high resistance. No?
Means it heats up faster, is it?
It get hotter faster. No?
Oh, okay.
Resistivity of semiconductor is between both metal and non-metal. No memorize. Just know roughly the magnitude. Resistivity is usually about 10 to the power minus 8 for metal. The most common one used in the exam for practical is constant lah. This is about 48 and 10 to the power minus 8 ohm meter lah, because it has a high resistance. Determine the resistivity of wire. You can use a battery or power supply. Voltmeter to measure the potential difference across the length L. Ammeter to measure the current flowing through the conductor or wire. Procedure: use same wire throughout the experiment. That means same cross-section area lah. A is constant. Change the length. Right? Change this length and measure the with a meter rule the length. Each time read the voltmeter reading and ammeter reading. Tabulate L, V, and I. Then calculate R by V over I. Do not slide. Right? Don't do like me, slide like that. Take it up. Right? Take it out and then put it there. Don't slide like that. You remove the uniformity. You scrap the wire. Do not slide the wire as scrapping remove the uniformity of the wire. Then A is no more constant already. Right? We want A to be constant. Plot a graph of R against L and the gradient. That's your gradient. Rho over A. Right? It's a straight line. Okay,
Yeah.
keep the temperature constant by switching off the circuit when not in use. Measure the diameter of the wire using micrometer because it's quite thin at different places. And then find the main diameter. Length using the half meter rule. And use the area, use the formula for cross-section area by R square. Calculate your cross-section area. Then resistivity equals to gradient times A. Okay with that?
Okay.
Right? Special resistor. That's your fixed resistor. That's your variable resistor. This is a thermistor. This is a light dependent resistor. What is this one? What is the symbol for this one?
This is what do you mean?
Yeah, this symbol, what is it? This symbol?
Resistor?
Yeah, this symbol. A rectangle with a wire passing through. This symbol.
Isn't that a resistor?
No, a fuse. Right? Basically, if too much current, the wire will break. Then the current cannot flow. That's why it's called a fuse. Fuse, an electrical safety device consisting of or including a wire or strip of fusible metal that melts and interrupts the circuit when the current exceeds a particular amperage. Okay, so if it got cut off, I will want to come back about 10 to 15 minutes time. Finish it off.
Okay.
Right, what is this one? What's the symbol for this one? What's the symbol tell you?
What you mean A?
A is what?
I have no idea.
Piezoelectric crystal. B is what?
Huh?
This one
B
you
is a
study in A2 lah. B is what?
thermistor.
The Mr. C,
I
strain
don't know.
gauge. D,
LDR. Light dependent resistor.
E,